Okay. The group of Kashmel, Robin, and the rest. Sa ito yung kuyog. Murag kamo pa may ako na. Ito pa may ako na dunggat. Sige. Let's have that one. Kana lang mo report please. And ang mag-open sa cam. My laptop is still in the service center. Hopefully na siya next week. Mabagal siya. Okay.
Miss. Hello?
Sige, please go, Kashmel.
I thought like ano pa miss like wa pa na ko nabutang like changes sa illustrations kay I thought mag-continuation pa sa B-Star.
Sige, okay. Continue lang muna sa B-Star. Sige, okay. So, wind up. Siguro mga hopefully 30 minutes so that we can start with the next one. Okay, sige, Kashmel, please.
Bro. Hello.
Si John. Sige, go, John.
Isang lag. Bro kami sa? Okay. So good afternoon everyone. So today I'll be discussing about B-Star trees. So unfortunately B-Star trees doesn't have much information. Gamay ra jud kay information niya then nasa book like katong sa file structure kay anak ko na niya kay ang properties ug nasa mi nakita lang information kay sa Geeks for Geeks but dili siya kompleto. And it was stated there nga ang B-Star trees daw kay rarely used because of its complexity, especially sa kani iyahang division apart. So let's get to what is in the slide. So B-Star tree of order M is a search tree that is either empty or that satisfies these properties. So based sa katong book, ang B-Star tree daw kay has the same property as the B tree. So every node has a maximum of M descendants. Every node except for the root and the leaves has at least 2m-1 divided by 3 descendants. The root has at least 2 descendants and all the leaves appear on the same level. Miss? Hello, Miss?
Muted ka miss.
Mute, Miss.
Yung electric fan dyan kay mas usog siya.
Sorry.
I know it's hot. Hot bitaw sa diri sa amo.
Okay, paningkor akong kamot, Miss, kay mo kuha ng lain kayo sa kuhan kung panington. Sige. Isang ka. So, okay na, Miss.
Okay, John.
Sige.
Sige.
So, yun, so all the leaves appear on the same level and a leaf node contains at least floor 2m-1 divided by 3 keys and no more than m-1 keys. So basically, B-Star trees, bisa katong file structure kay same lagi sa property sa B trees. Ang kalahian lang gid niya sa akong nabasahan, ang kalahian lagi sa B-Star trees kay o sa B tree kay kung kano siya sa mo-split. Ang sa B tree manggod mo-split siya if either sa left or sa right child kay makuha yung maximum key. Like for example, mapuno na yung maximum key, kuha na middle element, then i-promote as parent. Mao na ang sa B3 sa iyang pag-split. But sa B-Star trees, that is not the case. Ang basihan ra gid niya ang right child. So to understand more, let's go to the simulation part. So, okay. Let's have this example data. So, we have 113.18.4, 8.4, etc. So, for example, we try to insert. So, kay kanta 3 of order 5. So katong atohang rule. So, m-1 kay 4. So, maura na ang number of keys nga masud sa atong node. So, for example, so we try to insert 1. So, if there is a pseudocode. So, if the tree is empty, allocate a root node and insert the key. So, what we will do kay insert sa ang mga elements until mapuno ang key sa karing node. So we insert 113 pero ikuha na karang in ascending order siya. So we try to insert 8. So this will now become 1813. Then we try to insert 4 again. Then this will now become 14813. But so sunod nga kuan, di ba kay kuha naman siya full. So what we'll do, so if the node is full, we go to the splitting na. So karing sa atong kwan, if right sibling is empty or not full, so since wala pa man tayo right sibling, so mo ato ta sa else statement. Amo na to, then we will use this formula para sa ato ang pag-split. So karing nga kwan, mao na yung pagpangita nato sa atong parent. So what we have here, so 2, we have an m, a value of kwan m kay 5. So 2 times 5, 10 minus 1, 9 divided by 3. So it is equal to 3. So ang pasabot aning 3 kay for every 3 gaps, the next element mao na ang parent. So 1, 2, 3. So the next element, so mao na siyang mahimong parent. So kari ang atong parent kay 8, while karing 1, 4, 6 will become the left child, and karing 13 mao na atong right child. So og atong i-visualize, mao na siya ang may tabo. So next time. So Miss?
John,
Yes, Miss?
isn't that going against the rule that the minimum number of children or the minimum number of keys, for that matter, there is a set number? So are there exceptions to the rule?
Wala kang kuan ra bitaw, Miss, karang dili bitaw kompleto gid ang karera gin simili, dili ko sure kung kuan, pero kuan bitaw kay ang start trace karang dili siya kompleto information, like sa karang cases naba say kuan nga cases ang ulo juga usually kuan.
But the book provided the characteristic, right? That the number of keys so it is much the properties.
Yes,
so if that is the case, then there is a reason why those properties are specified. And then is this against the property? This is against the property because like you said that what is this? 6. Di ba dapat ang maximum 2, di ba dapat 2/3 full?
Oh, 2/3 full.
2/3 full. So what happened to 2/3 of 6 is 4.
Hmm.
2/3 full niya ano man ni siya ngayon ani man ni siya.
So, pero sa kuan, Miss, kahit murag sa way sa karang pag-split niya, karang gigamit nga formula sa pag-split mao. So
di ba 2/3? So dapat ang minimum number will be 4?
minimum number sa karang keys nga
number, oo, 4 kada block. If 6 ang yang maximum, then 4 ang yang minimum kay 2/3 full man eh.
Di, ang miyang...
Are you sure? Now, 2/3 full na ako. The floor of 2m minus 1 divided by 3. Divided by 3 ni? 2/3. M is 5. 5 times 2, 10 minus 1, 3. Murag floor or ceiling or something ni. Dili lang ni siya na ay a floor of that. Okay, what I know is 2/3, ano ni siya, 2/3 full. 6 man na siya, but 2/3 full of what, keys ba or pointers?
Miss, karang
is it 2/3 full of keys or pointers? Noting down that number of keys is 1 less than the number of pointers or descendants, if you want to call it.
So, di mo kung saan pag-answer.
Anyone in the group can help? So, dili na pag-split. Because you have to follow the rules.
Wala, bita kayo.
You have not read the book properly. There was kind of...
sa book,
yes.
Ang sa book, magod, Miss, kay gipakita niya ang properties dayon ang iyaharang kuan kay ang katurang pag, pero wala siya gipakita kung as unsaon pag ang process gisa pag split kali, Miss.
Naa sa libro that naay exception ang root node. The root node is bigger than the others. Because sa root node, it has to be bigger so that in-split niya ma-satisfy gihapon niya ang ang number of children. I mean, ang 2/3 gihapon in-split. That is one of the exceptions. A possible solution to that problem. Kay ano man ni siya? 2 to 3. Split man ni ang pag-split gani ani niya kay 2 nodes, 2 to 3. 2 to 3. So ang 2 full nodes will be divided into 3 parts. So mo nang naa siya 2/3 full.
Sayop din so sayop din ako.
So sayop ni inyo ha. Sayop na yung inyong pagkuhan. Naabi dito sa book. Actually, naaman dito sa book a possible solution for that problem because mo gina siya mahitabo. Dili ma-full. Or could it be a exception to the rule? How is it done?
Sayop.
Kay mo ora man ni siya nga dili maka 2 to 3 split. Ang pasabot sa 2 to 3 split, ang 2 full node, tuha nga puno ang node, inig naga di-insert, split siya into 3. Muna 2 to 3 split siya. Nya kani kay dili. So is this an exception or sa man ni siya? Is this an exception to the rule and which one is better? Nya kani siya kay half full lagi ni siya.
Like gikuan pa man like karang if empty amurag ang example man ko dito sa more example sa
Sa
kuan kay
keys ni, wait lang ha. Asa nakaka-characteristic nga keys? Number of keys ni? Sibling, employed, shift, all keys.
like sa
Sa maning
insertion
else. What is, di ba M here is the
karang order
which is the number of descendants. Is that correct? Is M the number of descendants or number of keys?
number of keys nga masud siya sa kuan.
Number
So,
of keys. Ang
so
M, number of keys? Starting from Wayne, M, unsay starting from Wayne's group, B is equal, M is the
Number
Number
of
of
pointers.
number of pointers or number of descendants. So kung ang number of descendants nimo kay 6, so that means ang number of keys will be 5. Maximum keys. Pero sa imo laging illustration kay 4 lagi, anong 4 man?
Di, kaya ang M man miss kay 5. So the number of keys nga masud sa isa ka node kay
Okay, M is equal to 5.
Oo. So if
ang
M
keys is
na
equal
one,
to 4. Okay, number of
if-
descendants ang number of descendants.
ano ba descendants?
Ang M. Everyone?
So
Kay
masud ra
consistent
sa-
man ni gikan ni Wayne's group katong B3 nya B plus 3 and so on.
so na ang sa isa ka node kay masud ra kay 4 keys since we have a order kay 5.
So 5
5
ang
minus
order
1.
ani.
So 5 minus 1.
And then the floor. So that's 10 minus 1, 9 divided by 3, 3. So 3 ang iyang minimum keys. Pero mo lagi ni sa PICAS. Do you have any documentation na pwede ni siya inaani as a exception to the rule? John?
Miss,
Or is that your interpretation?
interpretation miss kung unsa pagkuan.
Naa sa libro, naa dito, one of the problem of the 2 to 3 split is when you are splitting the root because the root has no sibling. That means di ka 2 to 3 split. So naa siya mga solutions dito gihatag. And one of the solutions, as I remember it, is increase the size of the root such that you can still have the minimum requirements of number of keys when you do a split. I-postpone ang splitting sa root, so that means i-increase gud nimo ang size sa root node. Okay. So dili siya ingon ani. Dili ingon ani.
Sorry miss.
Okay.
Pinaglibog.
So
Lahi-lahi. Nasubkuan mo
So,
lang. Sige.
baka meron pang discussion or something that tells any naabay mga how do you call that one, naabay mga exception to the rule or something. Di manggugo ka remember. So, but if you can say nga na ay discussion on this site or authors na efficient ni siya nga way, because this, he was right. This is one of the problem of the 233. Di kay siya man 233. B star 3.
We start
Kaya
with
ang iyang characteristic good sa iyang splitting is 2 to 3 split, meaning ang two full nodes will be split into 3 nodes. And then in-split niya, dapat na pa iyang characteristics na 2/3 full. Kay si B plus 3 is half full man. So in-split niya, magkatunga man half full. Kani siya kay 2/3 full ang iyang minimum. Ang maximum niya of course is katong ang iyang order. Sige. So, ato na ning palabyon sa niha. So, wrong ni siya. Dapat mo split lang
sige,
siya
sige,
kung
mas.
ano siya. So, what will happen next when we go to next level? Sige, padayon sa ta.
Sige. Ay, karing, ay, pakita rin akong insertion, mas. Right. For example, if train 2. So,
sige, anila
ulit.
tumbuatan ha. Wala pa'y documentation nga i-present si John na suppose this is an exception. Pero ang exception ani sa root ra gyud ni mahitabo if ever na exception.
So,
Dili
ipakita
ni
lang
siya
ako.
pwede nga naa ka dito sa ubos. Otherwise, what's the purpose of making a rule nga puros na lang ka exceptions? Sige, ato ning i-assume karon but John has to look for a documentation nga exception ang root. Kay problema gid siya ang root. Ang when you split the root, problema gid siya sa kaning B star 3 because of that limitation na wala siya sibling. Sige, go John.
Sige. So, karing, if it, so if mo insert tag, for example, next kay mo insert tag 2. So, we search for the appropriate node for insertion, insert that key in ascending order. So, since 2 man kay less than sa 8, we go to the left child. So, the left child, will compare. So, the left child will now have a 1, 2, 4, 6 keys. So, next, kay, mo insert tag 7. So, since we compare 7 sa kariya to ang root nga 8, so, since this is lesser than 8, so we go to the left child. But nakuha naman na to, full naman siya ang key. Di ba? If sa B star ni siya, kay insert dire ang 7, tapos kuha na tong middle element, then i-promote na to as a parent. But katong giingon pag earlier, kay dili siya nga na ang case sa B star, based sa katong gigs for gigs. So what we will do is, so since the node is full, if the right sibling is empty or not full, so what we do first is we shift all the keys in the right sibling to the right and insert the previous parent. So i-shift na nato ang 13, so isa forward. So this will now become, ang karing 8, i-add to na to sa right child. So the right child will now have an 13 8. So karing 8 mo itong previous parent. So next is that we shift the last element of the current node to the position of the parent. So ang karing pasabot ani kay ang karing 6. So you shift the last element of the current node to the position of the parent. So ang karing last element na to kay 6. So 6 will now be promote as a parent. So mao na ni siya. Tapos i-compare na to again ang 7 sa iyahang sa karing root sa karing lagi parent. So we compare 7 and 6. So since 7 is greater than 6, so we go to the right child. So this will now become 7 and 13.
Uy, teka lang. Teka lang, murag dili yan na modern rule. It's basically the same rule at what did you do, Kashmel, when you do an insertion here? So ni overflow ang PCAS, you just do adjustment. Nganong si 6 na taas naman hinuon siya na
ang if i-move man ang kuan miss, ang karing sa left since 7
nganong
man
ni move naman, nganong dili naman si 7 ang gisaka and then si 8 ang nanaog.
Okay.
How do you do, sige, in general, how do you do merging? Kaya kani merging man ni siya. So how do you do that? Imo ipasaka daan? Exactly. How do you do? Because you need to know the process para kay mo how to program.
So, like for example, karing 7, 8, so, diri man sa left, then mag sa left, then kuwaon niya ang last key.
Sige, you tell us how to do and what would be the efficient way of
sige.
doing that one.
Sige, ako ikuan. If sakto ba akong pagkuan, maklaro ba na ako pag So, kari 7, di ba? 7 i-compare nato siya sa 8. So, mugyo to the left side. So, sa karing left side, atong last key kay 6 man. So, dira siya mag-point ato na siyang i-remember nga atong last key kay ang 6 sa left side. So, since kari lagi pasabot this is kari full naman siya. So, dili siya pwede na ma-insert dinhi. So, based sa kaning sudok code na to, okay? Based sa kaning atong sudok code,
asa man sa imong sudokod? Where in your sudokod?
if the node is full, if right sibling is empty or not full, di ba? Ang atong right cell kay 13 ra may sud. Tapos dili pa man siya full, di ba? Napa man siya karang extra spaces. So, musulta sa if statement, then we shift all the keys in the right sibling to the right and insert the previous parent. So, atong buhaton, di ba? We shift all the keys in the right sibling to the right. So, atong i-shift ang 13, move na tong 13 diri sa right, dayon i-insert na to ang previous parent. Di ba? Atong previous parent kay 8 man. So, this will now become A13. So, di ba? So, next, we shift the last element of the current node to the position of the parent. Since kato galing kaniya, since 7 is lesser than 8, we go to the left side. Diba?
Did you insert 7 in the previous?
Wala pa, miss. Wala pa, miss. Wala pa insert. Wala pa mag-insert diri ang 7. Since pag kuan man diri na full naman siya. Full naman diri sa kan dili makaka-insert sa left kay na full naman ang maximum nakuha na maximum keys. So, diri sa second kay shift the last element of the current node to the position of the parent. So, the last element of the current node, di ba, ang last element sa current node kay 6 man. So, i-add ang karing last element sa karing left side, mo na to parent ron. So, this will now maato siya sa babaw, i-promote siya as a parent. So, on 6 na siya sa parent. Then we compare again 7 sa 6. Kuan ra. Okay na. Sige. Padayon pa. So, we compare again 7 sa katong parent. So, 7, move mo sa giya. So, since 7 kay greater than 6 man siya, so mugyo to the right side. Dayon, sorted gihapon siya. So, this will now, so ang karang right side, mahimo na sa 7, 8, 13. Okay na.
So, where is the insertion of the node there?
Oh,
I'm looking at your pseudocode. Where is the insertion of the node?
Okay. Use the gap in your own to use the gap in your own node to rearrange and fit
in your own node.
Oh.
So use the gap in your own node to rearrange and fit in the new key.
Para ma-sort siya in ascending order mismo. Like gamiton ang karing extra spaces nga empty para makuha nimo. Like mag-move.
There's something messy here. Sorry, ha? There's something messy because you're inserting something. I'm trying to figure out the algorithm. Everyone, can you look into the algorithm, especially the group presenting this? Dili ra ni kang dyan na responsibility, but the group's responsibility. I couldn't understand or what is the ano there nga, how come si 6 na move put si 6? This 6 could have been just put there. What is the significance of moving 6? And why is that use the gap in your own node? What is in your own node? To rearrange and fit into the new key. What does that mean?
Ang pasabot niya, Miss, kay
is this found in the book? Mo ni siya butang sa libro?
Di, Miss, sa Geeks for Geeks ko nag-base. Geeks for Geeks, Miss.
Si Geeks for Geeks. What is that? Kulang yun siya. Okay. The tree is empty. Search. Node rich. Search the appropriate node for insertion and insert the key in ascending order. So in Geeks for Geeks, what is the meaning if the node is full?
Ang pasabot
Full
nga,
is
miss.
different from overflow. Is this because you were using the word overflow before? Ang discussion ni ano is overflow. Ang akong problema ani kay nag-discuss mo gamit ang libro na term sa B3, B plus 3, tapos ni-shift mo og lain nga source sa B asterisk 3 na lahi ang ilahang way. So matwisted ang the way we are going to think because lain-lain ang ilang implementation. So you're using the book in B3, B plus 3, tapos you're using another source for B star 3. So dapat ni-follow lang ang mo sa libro and then you will tell us, but in Gigs for Gigs, it's like this. Karon you're giving us a new way of doing things. Walay consistency between the B plus 3 and the B star 3. When in fact, parihura ni sila, and then the B star 3 is just 2/3 full and the B plus 3 is just 1/2 full. Meaning, ang minimum number of elements is half sa B plus 3 and then ang sa B star 3 is 2/3. Nya karon kay na change ang inyong pamaagi kay ang Gigs for Gigs lahi sad ang iyang implementation sa B star 3. Lahi sad ang iyang gigamit para sa insertion. So what happened here? And is that logical that i-move the kang gi-move and then unsa na siya? Do they have like a working node that puts everything there and then decide which one will go to the left and which one will go to the right nodes? Which one will go to the sibling, left sibling and the right sibling? Is there a working node? Nag-mention sila Wayne and sila, I think Robin failed to mention also the working node which is bigger than the usual node para there i-decide kung asa ang half or asa which case will go to will stay in the original left node and then which one will go to the left sibling and then right sibling. So can you do an explanation asa siya dapit nga mag-mention nga ma-split siya. So notice here na mahimo man ni siyang when you insert 7 to no, so mahimo na
7.
siyang 7 kabuk entries. When you insert 7 put kabuk entries. Ano na ingon ani man ni? Is there a mention of exceptions on saon nganong naingon ani ni siya? What happened? Kani ko kasabot aning use the gap in your own node. Nganong na own node? Your own node pa gyud. Use the gap in your own node to rearrange and fit in the new key.
Pero kung pasabotan na miss kaya ang karang
Tanawa ha. When you say shift all the keys in the right sibling to the right, to shift all the keys. So usa ra man to ka key ganina 13. So siya ra ang i-shift. So nganong na-shift naman na siya further away. Duha na ka position ang gi-shift niya.
Ay ko man miss karang yung ascending order mo na pasabot sa use the gap in your own node to rearrange and fit in the new key miss.
So that means dili ingon ana nganong ipa-shift naman niya. Nya pag human i-shift ulit. I-shift niya ka isa niya, i-shift na pagbalik. That is what you did. Shift all the keys in the right sibling to the right and insert the previous parent. So mo na ta to kay ang previous parent
katong 8.
Nganong na shift the last element of the current. Use the gap in your own. Nganong so ang akong gi-expect sa algorithm kay based on the algorithm kay 13 will be in the second position and 8 will go down in the first position and then 7 will go up.
Dili Dili.
Asa man na? Tanawa sa imuhang algorithm ha?
Sige.
Sige, ibalik ka god. Ibalik ka god dito.
Asa ta
Sige.
magkuan, Miss?
Katong wala pa na insert sa 7.
Oh, like
Kana.
ay,
Sige,
karang,
kana.
13.
Kana. Stop,
13.
stop. Stop
Sige,
there.
sige,
Stop.
Miss.
So, if right sibling is unsa na is empty slash not sa pasabot. If node is full di ay so munay full. Node is full.
Full man diri left.
Okay, if node is full and then shift all the keys the right sibling. Sorry. If right sibling is empty or not full.
Not full.
Sige.
No, not full.
Sige. Yeah,
Sige.
shift all the keys in the right sibling. So usara man na. So 13. Sige, shift ko no 13.
So shift ay wala ni na kuan. Na diretso ra ako ang kuan. So dayon.
And then that's letter A. That's I. That's I. And then double I, shift the last element of the current node to
the position of the parent. So ang current 6.
Shift the last element of the current node to the position of the parent. Ang last
element, di ba? Kay ang 7 kay dire man tato sa left side.
Anong masud ban siya din ha? So naa na sa working node. And then use the gap in your own node to rearrange and fit. Use the gap in your own node. Ano may node? Uy, working node man siguro ng node.
Mora.
What does that mean?
Pasabot man gura na may like for example, if sa may makuha na tapos for example kay 9. So dapat 8, 9, 13 or galing ma-ascending.
Everyone, will you please pay attention ha, because we might do some manipulation here. I might ask you to what will be in node block 1 something that is. So you can help also here. Muni problema when dili kompleto ang algorithm unsa nay pasabot ana niya. Because a possibility here is that since these are rearrangement, so ang gibuhat gi-combine tanan and then group. So akong nakitaan sa gibuhat ni John ha kay gi-combine tanan and then gi-distribute niya accordingly so that makuha ang minimum requirement na 2/3 full. Remember nga 2/3 full man na siya. John, tanawa lang si continue lang sa and then we'll try to figure out kasi na ma-figure out along the way kung unsay may tabo.
Sige. So, we'll proceed lang ko sa next element, Miss. So, like for example, akari simple naman kayo ni sila dito kay insert na may so. For example, mo insert tag 3. So since 3 is lesser than 6, kaya i-compare na to. So dire niya sa left side. Dire niya sa left side. Alam niya sayop niya dire sa kuan. So the left side will now become 1, 2, 3, 4. Then we go to the next element, we insert 11. So we compare 11 to 6. So since 11 is greater than 6, okay, we go to the right side. So right side will now become 7, 8, 11, 13. So next kay 15. Since 15 is greater than 6 mo ato sa right side, pero full naman siya. So we go to the else statement, which is to split niya gamit ang karenga formula katong ganiya. So we got 3 here, so mag-carry siya. Ang ato ni siyang i-like kare magod kay maghimo kag array yani. Maghimo kag new array, i-insert nimo ang value sa left side dayon sa parent o sa right side with kare ng new value. I-apelo nimo siya. Apelo nimo ang 15 sa pag-insert na in ascending. Tapos if ma-insert na nimo siya katong 3, imong basis para sa imong parent. So for every 3 gaps, the next element imong parent. So since 1, 2, 3, the next element kay mao ang parent 1. So balik na sa kasaglay gap parent 2. So if kana i-visualize nimo siya isa 3, so mao na niya ma-forma. More sa insert. Pero sa ang next maguduntaan niya kay deletion. Pero since deletion lagi pare gidi sa katong gi-state sa Geeks for Geeks kay complicated gali dayon wala sad sila ni ni hatag og kuan karang information about unsay process sa deletion. So murag kutob pa mi sa insertion, miss.
Wow. Ang libro wala nag-discuss og deletion or insertion
Sa
ay deletion. The book where you originally got that ano.
sa Geeks for Geeks.
No. You should have
The original book by Mike.
Hmm.
I forgot the name.
Michael J. Fox.
Yeah,
Sige.
Michael J. Fong. All he discussed there was the properties ba to? Yeah, the properties. And then he mentioned something na because of 233s because of 233s more na ay B star trees. That's what he mentioned there. But there is no like process ang operations etc.
So that means same ni siya sa ano, same ni siya
Yeah.
sa B3, B plus 3.
Oh.
So that means iyang deletion pareha pud sa B3.
Yes.
Except that you have to retain the properties na 2 to 3 split. Like what happened na-illustrate niya ang 2 to 3 split using a working array. If you notice, gi-illustrate man niya ang working array. Okay. Tapos, if you recall dito sa B plus 3, na ay repetition of nodes. So, kung na ay repetition of nodes, mahabilin gihapon, makuha gihapon nimo ang 2/3 full. So, ang iyang 2/3 kay 3 man. Diba sa computation niya, when n is equal to 5, ang 2/3 is 3. And notice here, na siya 2. Tanawa, 3, 3, 2. Pag naapata ito yung repetition, because ang repetition is just use, diba ang elements ani na sa bottom rapod?
Yes.
So, and then na ay repetition. So, kung na ay repetition, so na ay 4, remember the rule na the descendants of the first sub 3 are all less than key 1. And then the descendants of the second sub 3 are greater than or equal to key 1 but less than key 2. And then descendants of the third sub 3 will be less than or equal to key 2 but less than key 4. So, ma-maintain unta to na 2/3. Yes, Wayne. Depending on kaya nga we need to know the implementation. Kay it seems like there are no fixed rules on what mo bitong naglibog na kay nag-start sila sa B3 and then extend B plus 3 nga dito gikan na source o niya bago ni shift og laing source. And then pag shift sa laing source lahi ang characteristic. Like kani wala siya gihimong characteristic, algorithm lang. Ang adto sa libro kay characteristic ang iyang gibutang. Mga rules of what it should be. If you notice na ay usa ka block didto or usa ka kuan sa book nga mo ni rules, number of children, number of descendants, number of keys, number of descendants, and everything. So, murag ni gawas din hiya kay no duplicates. So, no duplicates, that means the data are inside interior node and leaves. Sumugawas, ang discussion din is pareha sa B3. Diba sa B3 ninyo walay repetition? So murag mas duol siya sa B3 kaysa B star. Unsa man gud siya nga 3? That is the question there. You did not give us man gud the definition of what is a B star 3. Ang ganina ang kang katong B plus 3 kay you give us a definition of what is a B3. So na atoy nag-compare sila sa B3 and then B plus 3. And gi-emphasize ni Cashmel na, was it Cashmel or was it Robin na,
Robin.
the difference between the B3 and then the B plus 3. So klaro sa ato nga naay repetition ang usa wala because the nodes are in. So what about the B star 3? Unsa man gud siya?
Mura siya same sa B3.
So is it near the B3 or is it near the B plus 3? So kung sa B3 siya, dili siya dili mo gawas kaning 2m minus 1 divided by 3. Unsa man ni siya, number of children man ni siya? Is there a list, a summary of its characteristic? Okay, this is the operation, the insert operation man. How about its characteristic? What is the wala nimo gi-discuss unsay iyang characteristic?
I think that formula specifies na the number of keys in the leaf node lang.
Oh, so
Yeah.
if you notice sa libro, katong gikuha niyo sa libro, na ato'y mga naay mga exceptions na kung leaf o kung ano kani, what is its characteristic? Because how can we check if the algorithm is correct if we don't know its characteristic? Dawaton lang nato ang iyang algorithm. Nga what kibaw unsa nga characteristic ang i-manipulate? Say what is the basis for writing this? Unsay mo na gid I have the problem with that one. What is really the characteristic of B asterisk 3 as discussed in Geeks for Geeks? That is my problem because sa libro I think i-discuss niya unsay characteristic. Asa na gud na can you post that one? I think katong sa libro na siya characteristic sa B star 3 ba? Can you
Yes.
check?
Naa
Sa B
siya.
star 3 na siya characteristic. Can you put there the characteristic and we'll try to see kung working ba di siya based on that characteristic. Considering that kato siya book ang kani sa Geeks for Geeks. Because we have to remember na what is in the internet might not be totally correct even if Geeks for Geeks pa na siya. Na mangita mo mitaw dang dapat libro ta mo base pero kay kung wala sa libro then kaya how can we determine kung correct ni siya or not? How do we know kung correct na siya or not? Kung wala ta kay baw unsay iyang gibasihan for such operation.
So for the characteristics actually was mentioned by John Daves nara sa before slides.
Sige daw ko no, go. And then that characteristic was taken from Geeks for Geeks? Or from the book?
Ang katong sa book same ra siya gibutang.
Ha? Asa man?
Kani, morning na sa kuan sa book. Then para sa katong simulation kay sa Geeks for Geeks.
Nara siya. The root has at
Yeah.
least the root has at least 2 descendants.
Morning na sa kuan mis copy ra na ko.
Pwede ang root 2 descendants. The leaves appear in the same level. And the leaf node contains sa libro ni mo gikuha.
Oh, sa book na miss. Pero ang katong simulation sa Geeks for Geeks to. Kay mas
Mo na problema.
kay
we do not know.
Maglisod ko visualize ko kuan ra mis.
Pero mo na problema kay we do not know kung mo ba ni gi-follow sa Geeks for Geeks. No, sa mga M descendants, okay naman. So, kung M descendant siya, so minimum of 2 keys. Murag ang sa book na ay, I will try to recall. Murag na siya exception na ang 2/3 full, ang exception adto is the root. Kay iyang i-divide into half. Murag naa siya'y it is, I'm sure it is found in the book na ato katong akong giingon ninyo, but more of a discussion. So what are the problems with 233 with B start 3 kan 2 to 3 split naa na sa libro. So ang iyang exception kay na siya. O kana Wayne. kana Wayne kana siya. Kana siya mga ano niya exceptions. Now, if there's no sibling, no 2-3 split is possible niya. Knuth suggested something. O, kana. Si Donald Knuth na siya. Kanang because possible pareho ra siya sa B plus 3. B plus 3. No. Dili ka maka 2/3 kung mag-split ka sa root. So, mo ani siya. This is the one. Kana siya. If no sibling, so ang possible solution niya is, kani to grow to a size larger than the other pages. Napaningon ko kanina, to grow to a size larger than pages so that kung in-split nimo into 1 to 2, kay because the root has no sibling, so siya ra ang mag 1 to 2 split. 1 to 2 split, the second, kay mo na siya. So, lahi og size ang root. Then, a second solution to avoid any special page handling logic, kana mo na siya. Na, ang iyang gibuhat kay hihimo na niya half full. So, ang exception niya sa root, kanang pinaka-last sa gibutang ni Wayne. So, kung half full sila, so katong pag-split di dyan kay dili inadto. So, gibahin good sila into dili to tong 3 diri niya, 1 diri. Ay, pila to 3 diri niya. So, gibahin good sila na half full. Duha ka book ang mugo sa other side. Mo ni dyan, wa ka kakitaan ni na kuan. Kining? If you wanted to have a 2/3 full. So, ang 2/3 niya kay tag 3 man. So, that means musud siya unom ka buok para mo full siya, full na ang 6 ka buok. Tapos, pag-insert ni mo pag 7 niya, then mas-split ni mo na siya 3 niya, 1 taas. So, instead na gamay ra siyang sulod, dako siyang sulod. Para in-split ni mo niya, 2/3 full siya. Muna pasabot sa sa kanang first solution. So, let the root, but then, iyang root ra. Ang root ra. Ang root node ra. So, duha ka solution ang iyang gi-offer. Ang one solution is, remember kay each node is 2/3 full. 2/3 full. So, except for the root. Ang root kay, ano man ang root kay, inigsugod nimo dito man ka mo fill up. So, yung first solution yang gi-offer is, idako nimo ang root. So, idako nimo para inikapuno. So, for example, kani, mo lagi ni kani siya na, split dapat ang minimum niya. Ang 2/3 niya kay 3, di ba? Ang 2/3 niya kay 3. 3 keys and then 4 for descendants. So, 3 keys. So, ang iyang buhaton is, ipadako nimo, himuon nimo siya og 6 ang root. Makasud. Inikasud sa isa, 7 na siya. So, in-split nimo. So, 3, 3, and then ang isa ka key dito sa taas. Kana siya. So, makuha na dayon ang requirement na 2/3 full. Yeah. Pero iyang ano pod ang iyang solution nga naapod siya advantage disadvantage nga gihatag niya siyang solution. So munang the other solution nga iyang gibuhat is exception ang anak sa root or ang mga children sa root dili sa siya mo 2/3 full initially, mag half full siya mo na siya half full nga ang muna siya ang pages descending from the root. So kung root na siya niya ang pages half full na siya. Pwede na siya maging half full. Pero kana ra siya siyang exception. So this is actually one of the things I think na wala ni Prosper ang kaninga tree kay kind of complicated to implement mo nang sa Geeks for Good kay siya ka-implement gani pa. But you can make up mo nang make up you make up you provide some rules siguro exceptions. Okay? Sige. So we can come up ang katungkang dyan ang iyang gi-illustrate siguro is pero sayop lang niya pagbahin. Ang possible na itong i-illustrate is itong half full nodes emanating from the root or a children sa root. Half full. Pagbahin niya, half full. Tapos, ang pagbahin sad, so, libog man imong gi-mention dyan because usually kung magbahin good ka, split, if you notice gikan sa discussion ni Wayne o discussion nila ni Cashmel, there is really a working node. Na dito nimo siya bahinon o determine and the best way to determine there to split is imo na gyud split into two. Dili kay katong usa ra ka buok node kay ngano like what happened in your case puno gihapon ang first node unya diri sa PCAS kay usa ra ka buok ni overflow ra dayon ni siya, so that's a disadvantage, mag-reorganize na pud ka, whereas kung gi-split naman lang gyud nimo into two, gi-half na nimo, the chances is naapay space diri na asay space diri. Did you see that one? Kay kung inanayon lang nimo nga gikuhaan na nimo isa ri diri ang kanimo first node, can you show that illustration? Gikuhaan na nimo isa diri and then iputin nimo sa PCAS node, ni overflow ra pud ni siya. And then once mag-overflow man good, then you have to do rearrangement. And rearrangement would mean a lot of processing time when you do rearrangement. So dapat pag rearrange niya na full man na siya, and then we use this we use the second rule as the exception, kaning half full lang ang ang children of the root node. So dapat pag split niya is direction na pila to insert unsa man ni insert kaning pag insert pa lang nimo sa 8 katong before that John.
Ay sige. Before
katong wala pa nag-create sa node, napuno pa lang ang katong isa.
Ay, katong
node pa lang.
Kari kani?
Kana. Pag split nimo gi-split na nimo, hati na gyud na siya.
Bitaw.
Dili kay 13 ra ang magawa sa PCAS. Pag insert nimo unsa man na insert 8, insert 8 ni. Insert 6. Pag insert 6 nimo, dapat na kay 1/4 diri, 6 dito sa taas, 8, 13 sa kabila. Because you will always assume na nabahin na ba nimo, so ang chances that you are going to rearrange soon will be slim na. Kay napaka-space diri sa imong first node, napaka-space diri because you already nag-rearrange na good kadto, ni-create na good kag bagong node. So kato siya. Munida kan siya analysis on amo ni siya algorithms and complexities. You're going to go look into what should be best. Siya. Dili kato nga imong i-shift. And wala man gud mo na explain properly unsa nang use the gap in your own node to rearrange. This could mean the working, I do not know, working something. Kay nagsigigid siya rearrange. So dapat ma-postpone man ang if na-split lang to siya properly, kay nag-split naman gud to siya, if na-split siya properly, then ma-postpone gamay ang rearrangement. Kato imong gibuhat kay pag insert nimo nag-rearrange, sunod nag-rearrange na pod, sunod nag-rearrange na pod. And so what is the solution now if naay sibling node and then full na siya. So how do you rearrange that one? Unsay solution niya to rearrange kung full niya dili pa ka mo create og new node, di pa ka mo split. Unsa na iya ha? Sakto ka niyang kuan, shift all keys in the right sibling. Anong right sibling man? What if ang right sibling ang napuno?
So,
Napag yun na siguro yung lain dyan.
Oo.
Yan ang ingon siya
kita
nga,
ay-
shift the
if
keys
right-
to the right. What if ang right sibling ang napuno? So kuwang na imuhang algorithm.
Gibasayan ako sa Geeks for Games niya. Kuha mo
No.
sa information. Niya naman sad siya nga. Kuha daw kay complex na kayo siya.
No,
Mura-
pero
mura-
you said that complete ang iyang insertion. No, ningan good siya. Right sibling. What if napuno? Ang right sibling ang napuno. So wala sa iyahang algorithm.
Wala.
So how do we manage? So man na nato, what will be the solution? Kashmel, how was it? What's the solution in nga imong B+3? Kung puno ang right sibling, you have to check the adjacent sibling, di ba?
The immediate sibling, miss.
The adjacent or immediate adjacent. So you start looking sa left and then you go to the right.
Right.
Right first.
Left.
For left. Left
Left.
first and right. And then emerge nimo.
I-merge nimo ang kanang napay space.
Emerge ang naay space. So that means merging here is bahinon gud siya.
Bahin, yes, miss.
Bahinon into half man to kay quad man to, di ba? Half
Ito nga
full
nimo,
man to.
ito nga, yes.
Oh, so mo sa di siya. Ang problema lagi ani niya. So bahinon kung magbahin naman lang gyud ka, bahinon gyud nimo properly para you can delay a little bit of your merging sa sunod. Naa kay space pa. Okay, so i-apply sa B3, sa B+3 pero with some exceptions. So kana siya. Okay, and then ang ako lang kon is nganong pareha siya B3 characteristic or pareha siya B+3. Asa man gyud ni dyan? Can you look for that one? Unsa man gyud si B*3? Is it
Murag sa kung
Okay.
kuan miss kay mura compare man siya sa kuan B3.
because based on the book, pwede ko ba sa'yo? Can you check on that? B+3 siya eh. 2/3 full lang siya. So that means walay repetition, naay repetition of node. The interior nodes will just be how's that? Mura siya og nodes that will determine where to find the element. Gulo siya ha. Sige.
It states here, Miss, na it makes it is possible that to define a new kind of a B tree called the B star tree.
So it's a B3.
Yes, Miss.
Because ang B3 Wayne is also half full. Wayne? Di pwede 1/3. Half full. Ang B3 is half full. Ang B+3 is half full. Ang B asterisk is B star. B star or B asterisk is 2/3 full. So there. Klaruhan na ninyo. Finalize na ninyo. Among grupo ha. Para i-summarize kung unsa gid siya. And then you can give the possible solutions of the problem. Kay dili siya. You cannot have a 2/3 full in when you split the root node. So what are the possible solutions and how to implement it? Again, mo na ni siya algorithm. So how do you make your processes consistent? Okay, so and when you are going to do deletion, kahit man lang klaro ang manual process, complicated nga ang complicated ang operations here because this needs to be recursive. Anong recursive? So that you will have pointers for all levels. And if you have pointers for all levels, you are able to go up. Diba? Tingin mo, bottom ang insertion. So, bottom niya mag-go up. Ang katulang sa inyong Cashmel is, you don't check the top node. Ang katong keys will be updated. Update keys na siya. So, after you reorganize sa iyang pointers, update the keys by looking for the smallest in that subtree. So, katong key 1, looking for the smallest in the second subtree. Yeah, key 2, smallest of the third subtree, and so on and so forth. Okay, sige. Question, clarification? Mag-drawing niya ta ani. Mag-question ako, maghatag ako drawing ni Kates, and then what would happen if this is the operation? Sige. So, John, klarohanin ninyo nga grupo. Okay, we go to...
Yeah.
Di, ako'y mag-drawing niya. Ako'y mangutana. Ipa-explain ako what will happen. Di makadraw eh. Can you draw? Upload. Tugay kayo ng upload eh. Di ko ganun. Lisod og upload. Basta ako na lang bahala. Ako na lang bahala, ini Kates. Magawas ang inyohang mga skills in terms of how to do efficient way of processing data. Okay. Nganong, why is it like that? Mga whys and mga hows. Sige. Okay? So maybe you just make a summary between the B star, this group B star or B star 3. B asterisk mo tawag yan na B star naman sige B star. Okay. So next group we have 24 minutes. Sige, ato na ni butangag schedule no para by hook or by crook mahuman na ni nato. We still have the group. Wala na siya. Yes, Ross.
Miss, ang red block ang sunod, Miss.
Yes, red block na ta.
Feel na ko kaya ra ang introduction, Miss.
Sige,
O ang
go.
properties.
Sige.
Okay, ang operations means
Ang operations more
Yes.
Sige.
Yes. So, ang inyong buhaton, ani, is every time you do an operation, dapat na atong mga characteristics, ha?
Yes.
yes,
Kaya
Miss Naara.
Masundan na to. Kay very challenging ang red block trees.
Yes, Miss.
Lingaw sad siya. Sige. We can start with the characteristics of the red block tree and an illustration. Then we'll have that one on Tuesday. Then, mo finish kadiyot ra kaining dynamic programming. As in, kadiyot ra kaining dynamic programming, red cutting, kadiyot ra kay na. Then you have group 8. Group 6 will go to, so next meeting, red block trees. Then we will have tries. Medyo kadiyot na sa ning tries. We can have dynamic. Ang sunod na to, tries and then dynamic programming. Then we'll have cryptography. Okay. Sige. Wow. Sige. Okay.
Audible ra? Tanan?
Yes, we can hear you, Russ.
Okay, sige. So,
Wow.
good afternoon, everyone. I am Rosso Calit from Team Oldies, and we are gonna present Red Block Trees. Together with me is Mario Dominic Daculan, Maurice Lanstezon, and Simon Rafael Yu. So, Red Block Trees. Dali lang ni ato lang ni breeze through basta more like common understanding sa iyang properties. So, kanang red black tree is what makes a red black tree. So red black tree is a self-balancing binary search tree. So it is kanang comparable to AVL since AVL is also a
Self-balance.
self-balancing binary search tree. But sa red black tree, that's why ang anong red black tree ang tawag niya is each node has an additional data that contains the color of the node. So either red or black. So a little bit of history. Red black trees were created by Rudolf Bayer in 1972. Although it was not called red black trees by then, it was called symmetric binary B trees. So binary B trees meaning it's a B tree of order 2, meaning it has it can have a maximum of 2 children and only 1 key. And then it was later renamed to red black tree by Robert Sedgwick and Leonidas J. Gribas in the year 1978. And then, so what makes a red black tree a red black tree? A red black tree has properties: the black property, the red property, and the depth property. And together, they constitute the rules of what a red black tree is. So the black property states that the root and the null leaves are always black nodes. So as you can see here, node 12 and all the null leaves are always black nodes. So null leaves are actually more, you can say that they are the children of leaf nodes, but they don't have keys or values yet, but they are considered black nodes in the red black tree. And the next property is the red property.
Ross? Hello. Hello.
Yes.
Ross?
Yes, miss.
Okay. Sige. Clarification lang sa black nodes. So when we do implementation, are there really, appeal ba siya sa implementation or wala?
For the implementation, the black nodes are not really kanang disregard na siya, but for the sake of kanang sa properties kay it is important that we treat them as black nodes.
Okay. So
Okay.
ano lang siya? Conceptual view
Yeah, kon lang. Sa draw niya, kung sa
Sa
ato pa sa
drawing.
drawing, mas masabtan siya if we treat it as black nodes.
Okay.
Okay, so
Sige.
that is the red property. So red nodes can only have black nodes as children. So in other words, you can also interpret this as in any path, there can't be double red nodes. Like a parent and a child cannot be red nodes, or a parent and the grandparent of a node cannot be red nodes. So wala consecutive red nodes. Nasabtan ra? Like this, ang child sa 6 is 2, which is a black node. Ang child sa 15 is 12, which is also a black node. And then the last property is the depth property. Every path from any given node to any of its null descendants, meaning these null nodes here, must have the same number of black nodes. So if let's use this kanang tree half as an example. So we start from node 11, the root node, and then we finish to this leaf node here, and we count that there are only 2 black nodes, 11 and 3. Same as here, this path, only 2 black nodes, 11 and 3. This path has only 2 black nodes, 11 and 3. This one has 11 and 7, 11 and 7, 11 and 13, 11 and 13, 11 and 13. So that is the depth property of a red-black tree. So these are the properties, and nakoy, yes, miss?
Ross, can you go
Yes,
back
ma'am.
to the previous, just a clarification, because you mentioned a while ago that those nodes at the lower part are black nodes. So di mo siya count sa ibon depth.
Yes, it is not counted sa depth. Although if you count it, it will still run through. But for the sake of uniformity lang, para sarang atong understanding tanan, for the depth property, we will not count the nodes, kaning black nodes.
Sige. Okay.
Okay.
So, klaro
So
lang.
here to
Okay.
kay if apilon gyap ano lang nga, if apilon na to siya 3 man gihapon awa, instead of 2 this is 3, and then this path also 3, this path also 3, and so on and so forth.
Okay.
Masabtan ra guys, pera. So mo to siya, pero dili lang kay kuan. So ang next nakoy gamay exercise, miss.
Oh. Sige,
For the
go.
class lang niya, chat lang ang answers, di lang tawag poll kay para pas-pas ra. So, red, black, tree or not, based sa katong properties and the kanang iyang description, so definition, yes or no. If no, explain why. Okay, so
Ato na lang ko sa yes. Joke. Wrong sabi ko. I just, sige, go.
so kani nga example, is this a red, black, tree or not? Chat lang guys. Yes or no.
Ato na lang i-poll. Joke.
Madugay niya, miss. Oh. Nice way.
So, one or
Guys?
no.
Yes na, miss. Kay programmer man ta, true man ang 1.
Oh.
Anyone else?
Wala ko sa right
Sige,
answer.
Yes. Okay, yes. Okay, sige. Sige,
Sige,
sirit
yes
na. It is a red, black, tree kay sa ang tanner properties kay na follow ra niya the red property, the black property, and the depth property na follow ra. So, this one. Yes or no? Guys? Okay. Yes. Ala, yes sila tanan. Okay. See, so this red, black tree is a red, black tree. So yes, it
That tree is a red, black tree. This
this
red, black tree.
this tree is a red, black tree. So next
Okay.
is kani.
Wala, butang yung gano'n. Dash.
Okay. Yes, again, no. 0. Okay, no. Okay, so it's very easy, mano, sa red property nga. We can see that it's not a red, black tree because it violates the red property and the depth property. Why? Because from the path of 8 to the child of 21, there's only one black node compared to the path from 8 to the child of 1. There are 2 black nodes. Diba? So, letter questions, wala ra. So, letter D, kapit na ta guys. Any.
May taginani daw ko ng test. Sige lang, magpagawas lang kong a few.
Okay.
Ay, when in a face-to-face class, magdagid sila ballpen nga red o black or color
yeah. Yes.
pencil nga red o black.
Because it's more easier to visualize mga with colors mo nang mas, yeah. So,
Gipadagid ako sila ballpen.
for letter D, so it's no because it violates the depth property. It's clearly ang path from 8 to the child of 1 has 3 black nodes, and the path from 8 to 5 has 2 black nodes. 8 to the child of 5 has 2 black nodes, and 8 to the child of 13 has 2 black nodes. So it's not balanced. It violates the depth property. So the next one, hapit na dyan ta. This one. I think it's easier one. Oh no. No. Sige. Sirit lang. Dali ra kayo man kay it is not red block tree because it violates the block property wherein the root node is
Must
red.
be.
Yeah, it has to be black. So kani last na dyan. Guys?
Okay.
Oh, yes. Okay. Yes. Yes. Wala yung nag-answer of no. Yes, tanan. Actually, it's a trick question. Dili siya by BST actually. If you look at the order of the elements, dili siya BST, so dili siya red black tree. Diba?
Kana muna klarong ko.
Oh, basin ina niyo ni Miss ang exam ba? So, i-check ninyo kay 'di ba sa definition sa red black tree, it is a self-balancing binary search tree. So binary search tree siya in its essence. So kung dili siya mo obey sa rule sa binary search tree, so dili siya red black tree. Sige. Okay ra, at least aware na tato if magawa sa exam inana nga style, 'di ba?
And in addition to that, please follow instruction in the exam. So for example, na ako inana ka question o niya yes or no niya explain. Ang first good ninyong answer dapat yes or no. Dapat muna inyong first answer kay wala gani mo yes or no, di mo you will not get the full credit.
Okay, so okay ra to guys.
Oh.
Okay.
Kato na yari ka niya. It's not a BST man. Muna
Okay,
yung reason.
dili siya
And
BST.
then the justification is not because of red property, black property, o sa ka property,
Depth property.
depth property. Oh. So ang yang reason kay it's not
Dili-
a BST.
Yes.
It's not a red black tree.
Yeah.
It's not a BST.
Yes. Okay, so next is for the space and time complexity of binary search, I mean red black tree, the space is O sub n, like all the trees, and the time is O sub log of n for search, insert, and delete, where n is the number of nodes. Okay, ba naman tayo ni tanan? So the variations of script of red black tree is kanang leaf leaning red black tree wherein it's easier to implement, where ang difference niya is the search function sa left leaning red black tree is log of n minus 0.5, so it's a bit faster, but dili kay siya maklaro if gamay ang data. It's only evident if daghan na kay kag i-process nga, like daghan na kay kag na insert, dako na kay ang tree. And then another is tango tree. So a tango tree is a tree that implements the idea of preferred paths in searching for a node. Like I wala kay ko ni in depth pero what I understand about tango tree is that it uses red black trees and other trees, like na dili man siya specific og order good ang tango tree na ay pwede one child lang, pwede two children, but ang iyang main characteristic is na siya preferred path in searching for a node to get there faster. So just like left leaning red black tree, ang iyang search is faster compared to red black tree, but the implementation is very complicated. Yes, miss.
So since you have this question is for AVL and for red black tree. So you mentioned AVL is also a self-balancing tree,
Yes.
and red black tree is also a self-balancing binary search tree or BST.
Yes.
So is it always the case that these two trees So that means ABL, the reporters for ABL will also answer this. Is it also true that they are always, or the red block trees or ABL trees are always height balance? Sige. Okay. So ABL 3, reporters of ABL 3, you're not yet off the hook. So since there is a discussion related, so check.
Yeah. Actually, naa siya compared sa AVL3, the red block tree has less rotations, but in turn is also less balance. Pero if gamay ra ang data nga process like sa atong examples karon, dili kayo siya evident kay mo present ra ang differences sa balancing og sa number of rotations kung dako na kay ang imong tree, like dako na kay kag data nga gi-process. So red block trees has faster insertion or delete due to less rotations compared to AVL, but in turn AVL has a more balanced tree due to very strict balancing rules. Yeah,
So did that answer my question?
kind of more like this.
What does that mean by less balance? Dili kayo balance. What does it mean when you use the word less balance? Less rotations, that's clear to us. But when you say less balance,
I like
dili kayo balance?
in a sense, miss, kay like nakoy kuha nga information from Geeks for Geeks. This is the one. Mao ni ang ilang example sa red block tree, and if you notice, if kani ang implementation sa AVL, dili yun ni siya balance given sa balancing factor. It depende sa computation sa balancing factor. But for a red block tree, this is already balanced. Mo nang kaning example kay makita na to ang difference sa iyang balance, like less balance yun ang red block tree compared sa AVL.
So there are situations wherein the red block tree is not height balance.
Yes, miss.
Okay. See.
And for the original version, we got this from Algorithms 4th edition by Sedgwick. Actually, in his representation of red block trees, the nodes are not the ones with the color. It's actually the link to the nodes. But if you look at the definition of the structure here of the class node, you can interpret it as ang node mo ay may color. Pero sa iyang representation sa book is that the link has the color. The pointer to the node has the color mo na. So,
Kasi naglisod siya color.
actually, a bit of history, nganong red o black ang color ang gigamit kay, like, pag nag-release og paper si Robert Sedgwick pag 1978, titled A Dichromatic Framework for Balanced Trees. So dichromatic meaning using two colors to represent trees. Nganong red, the black is understandable kay it's like universal color for print man. Red is actually nindot siya og printing color sa una ba. So mo like gamit, and I think ang red kay mas cheaper sad siya i-produce ang ink compared to other colors. So maura to for the introduction sa red black trees.
Okay, so
I
hope
sneak peek sa structure.
sige, sneak peek ha, or sneak preview.
Preview lang. Inani ang structure sa red black trees, guys. And it will be discussed further by Maria Dakulan. Maka-discuss pa ta, Miss Dili naman.
Ayan na. Ayan na.
So,
Okay,
kana
kay
lang.
magklase ra ba ni sila? Wala, 2:58 pa. Napay 2 minutes. Yeah, magklase ra ba ni sila sa calculus. But I like your presentation, Lingaw.
Thank you,
Sige,
Miss.
okay. And the
Thank you,
color,
Miss.
I hope na malingaw mi as in sa next one. That's good.
More challenging yun ang red block Chris.
Yes.
Pero masabtan naman yun. CS man,
Okay.
CS students man.
So ano lang, when you're going to present, put a summary, a little summary of the properties on the side
Yes.
sa inyong presentation kay you cannot remember all of the properties.
Inig-insert
And
o
then,
delete me.
yes, inig-insert o delete.
Kanya,
Kaya,
side
add-
note sad, ang kaning red block trees, ang among discuss kay insert lang o delete kay, if you notice, BST man siya, ang iyang search kay BST ra sad ang search. And you don't have any differences sa code or sa the time complexity sa search. Same ra gyapon sa BST.
sige, kato lang siya. And then, ang rules kay na para ba na siya grandfather, uncle, blah, blah, blah.
yes,
Sige.
ma'am.
Butang
Yes,
lang
we
sa
actually
kilid.
have slides, Miss, containing those.
Yeah,
mga
ako lang
rules.
koan. Please submit para I will see.
Yes, Miss.
Para easy.
Will
Pero
do.
so far naman, okay naman. Ay, 2:59 na. Yes, Wayne, you have a question?
Yes.
Dili lang, ayaw lang ibutang daan while wala pa ang discussion.
Okay, base
Kay
na correction.
tendency is dili. You email it to me na pero
Okay.
ang kuan kay ay di na lang kumusod kay kanang magbasa na lang kuan or something. So after na sa discussion, Wayne.
Okay.
Yes, all those nga done na siya. Sige.
Okay.
Okay, sige. That's it everyone and thank you very much. At least dili kayo sakit sakit sa